Sir, you are not audible.
Okay. Let's see how. See, here, let's see what is integration by parts. As the name suggests, right, you're going to split them into two parts. And if I have to give you a similarity of where this concept comes from, in differentiation, you have something called as a product rule, right? So in product rule, what you do, you try to treat them as two different functions and then start the differentiation process. In a similar way, here what you need to do is you will have two different functions which are multiplied together. If it is addition, you don't have a problem. Addition, subtraction, you don't have a problem. But when two functions are multiplied, then how you are going to approach. So in this section, we describe one more method of integration that is found quite useful in integrating products of functions. So you need to underline the word products of functions. Right? Suppose if I have two differentiable functions u and v of a single variable, this is an important point of view. So what do I have? I have two functions in my hand, and both the functions are differentiable. You give the names to those functions as u and v, where they are functions of how many variables? A single variable. For example, let's say it is x, because that's what we generally use, right? Then by the product rule of differentiation, what can you do? So if I have d by dx of u into v, then what do I have? U into v dash plus v into u dash. So this is what the product rule of differentiation mainly speaks of. Right. But what is integration all about? Integration is about the reverse process of differentiation. Means I need to take this dx to the other side and then I need to start integrating. Is that right? Right. How do this? So as I mentioned, d by dx of uv will be equal to u into derivative of v with respect to x plus v into derivative of u with respect to x. Right. This is the first step. Now I'm taking dx to the other side. When I take dx to the other side, what do I have? d of uv is equal to u into dv by dx into dx accepted plus v into du by dx into dx. Is that right? So if I integrate on both the sides, then what is going to happen? If I put integral of d of uv, then it is going to be integral of u into dv by dx of dx plus integral of v into du by dx of dx. I hope you're in agreement with this. Right? Now what will happen is integral and derivative are counter operations of each other. So what will happen? They get cancelled. So what are you having? U into v is equal to integral of u into dv by dx into dx plus integral of v into dx by dx. If you see, basically, I won't call these steps to arrange at this step. Right? So I try to arrange at this step. Now what I'm going to do is a small rearrangement where I'm trying to write u into dv by dx of dx in terms of other two parameters. So what I'll do is I'll take this v into du by dx of dx to the other side. When I do this, that is, if I shift this value, this integral value to the left hand side, I get integral of u into dv by dx of dx is equal to uv minus integral of v into du by dx of dx. Accepted? Right? Suppose in this particular expression, or I'll say in this particular expression, right? They both are the same. So in this expression, if I say u is a function f of x and dv by dx is a function g of x, Okay. What am I doing? I'm not directly taking the function. What am I doing? One is a direct function u, and the second is actually what? Derivative of some other function. You're able to understand? So if I take dv by dx as g of x, now if I take u is equal to f of x and dv by dx as g of x, is it clear to this? Is there any confusion? Are you guys clear? Right? So if I take u as f of x and dv by dx as g of x, observe what is going to happen. Here I have u into v. So if I have to write this u, what will I do? I'll take this f of x and directly substitute it here. But initially, what is the function to which I'm trying to do the integration? I'm not directly integrating v, rather I'm integrating the function dv by dx. Right? So if dv by dx is g of x, then how will I obtain v from it? Yes. So what I'm going to do is, I'll consider, let me write this. So from here, I can write v is equal to integral of g of x with respect to x. I hope you are accepting. Right? So where am I going to use it? Now look at this whole. This is actual formula, but look at it. So for u, I will substitute f of x. For v, I will substitute integral of g of x dx minus integral of, I have v. So in the place of v, what should I substitute? I directly substitute g of x. Whereas in the place of du by dx, what am I supposed to do? I have u in my hand as f of x. Then what is du by dx equal to? F dash. Are you guys able to understand? So these are the four parameters which are going to exist on the right hand side. And this particular mathematical expression is what you treat it like a formula to solve problems using by parts. Okay. Not every time it is going to be this complicated. I just showed you the proof. So for logical purpose, we discussed all these things. I'll tell you a method of how you can directly solve this. Don't worry. What about the second term? In the place of v, you will substitute integral of g of x. In the place of v, you will substitute integral of g of x. In the place of du by dx, you will substitute f dash of x. So, there will be another. Right? Please make a note. Are you guys clear with this? Okay. Now things will become simple. See. Now, remember this step. So remember this step. From here, I'm going to rewrite the whole expression again. Observe what I'm doing. So what do we have in our hand? Integral of u into dv by dx is equal to dv by dx of dx is equal to. What is the mathematical expression that we wrote? Is equal to u into v minus integral of u into, what do you have? Integral of v into du by dx of dx. Right, I repeat, integral of u into dv by dx. So I'll write it again so that you can remember. Please write it along with me. So integral of u into dv by dx of dx is equal to u into v minus integral of v into du by dx of dx. Right? Where u is what? F of x. V is what? Or dv by dx is basically g of x. Right? And du by dx is f dash of x and v is integral of g of x dx. Now what I'm going to do is I'm going to use these terms to exactly replicate all the terms. See what I'm going to do. Integral of, in the place of u, I will take this f of x and substitute. So it becomes integral of f of x into, in the place of dv by dx, what is dv by dx? G of x, I wrote g of x. So integral of f of x into g of x dx is equal to, what is u x? U is f of x. U is f of x into, in the place of p, what can I replace with? Integral of g of x. Integral of g of x dx minus integral of, again, in the place of this p, I will put another integral. See, observe, there is an important step. Within an integral, you have another integral. So, integral of g of x dx. Okay, into, in the place of du by dx, I can replace with f dash of x. Into f dash of x with respect to x. Okay. Now, this is what you call it as an equation or a formula or whatever you want to call it as for y-dots. So, observe it clearly. What is happening? Integral of product of two functions, f of x and g of x, with respect to the same variable x is defined as f of x into integral of g of x minus integral of g of x into derivative of f of x dx. Okay. If I have to make it this, I'll call f of x as first function and g of x as second function. So I'll not suggest you to remember anything of this form. Okay. So till now, whatever we did is only for understanding why this expression is actually called. Okay. It is always safe for us to understand these. Now, what we are going to do is the next part is application. For application, I will definitely not suggest this. Okay, I'll tell you a method to remember. What you will do is you will write f of x as the first function, g of x as the second function. There is a rule to choose which one as the first function and which as the second. I'll come to that next. Okay. So first function is f of x, second function is g of x. Observe. Can I say the integral of product of first and second function is equal to first function, right? F of x is first function into integral of second function minus. Okay. Then what do I have? I have another integral minus integral of, one small change I'm going to do here is this integral is there. No, I will just swap the positions so that it becomes integral of derivative of first function. Repeated, integral of derivative of first function into integral of derivative of first function into what you have here, integral of second function. So if you observe, is there not, if you observe a pattern here, first function you write it as it is. Then you will integrate the second function. You put a minus sign. So starting with plus, you have a minus sign here, alternate sign, minus. You are again putting an integral. Now what you are doing, instead of writing the first function as it is, you write the derivative of it. Integral of derivative of first function into the same thing getting repeated, integral of second function. Are you able to understand? So as we update for 5 to 6 problems, you will understand. You cannot do that because you have another integral. There are two integrals. So it is clear. I hope everybody made a note of it. Only those functions, those integrals are only function for which it is a constant. So, no, you have a rule there. There is something called as islet. So we have written integral of x into g of x. F of x is integral of g of x minus integral of g of x f dash of x. But what I did in the next step, I just swapped the values. I hope you remember, right? So based on this statement, we are going to solve the problems here in this exercise. But before that, I told you there is a priority list that you need to follow to choose which one as the first function and which as the second function. And the rule that you use is called as islet, where I stands for inverse trigonometric functions, L stands for logarithmic functions, A stands for algebraic function, T stands for trigonometric function, and E stands for exponential functions. Okay. So I stands for inverse trigonometric functions, ITF. Okay. L stands for logarithmic function. A stands for algebraic function. T stands for trigonometric function, and E stands for exponential function. Meaning of this is, suppose I give you a question like this: integral of sin inverse x into x square dx. Find the integral of this central thing. You can definitely not do it directly. You need to go with by parts, because where you talk, so sin inverse x is one function, x square is another function. So among these two, according to this rule, which one should be taken as first? Sin inverse should be taken as first, and x square is it an algebraic function or exponential function? It is algebraic. If the base is having a variable, it is algebraic. If the base is a constant, then it becomes exponential. For example, 2 power x is exponential, whereas x square is algebraic. Okay. So among these two, which one is first? Sin inverse x obviously is first, and x square is obviously second. Is it clear? So, with this knowledge, shall we get started with the problems? First question is, find the integral of x into sin x dx. So if you observe, among x and sin x, which one should be treated as 1? X should be treated as 1 because it is algebraic, and sin x should be treated as 2 because it is trigonometric, algebraic and trigonometric. Is it right? So what is the equation telling us? Let's write down the formula. Integral of f of x into g of x dx is equal to first function into integral of second function minus integral of derivative of first function into integral of second function with respect to x. So here if you observe, integral of g of x dx will come, so there will be 2 dx on the other side. Okay, so this dx is with respect to gx, and the outside dx is with respect to the function that is obtained here. Am I clear? So based on this knowledge, let's see how to solve this. So how to do this? F of x is x into integral of sin x dx minus integral of derivative of first function into integral of second function x. So x into what is the integral of sin x? What is the integral of sin x? That's minus cos x minus integral of derivative of x is going to be 1. So derivative of x is 1, integral of sin x is going to be minus cos x. So what will be the answer? Minus x cos x plus integral of cos x dx. So it will be minus x cos x plus sin x plus. What is it? Minus x cos x plus sin x plus. So this will be the word answer. Is it clear? Shall I proceed? So the second question is integral of x into sin 3x dx. So again, x is going to be the first function, sin 3x will be the second function. So first function, so answer should be first function into integral of second function minus integral of derivative of first function into integral of second function respect to x. Right? So what is f of x here? X only. X into integral of sin 3x dx minus integral of d by dx of x into integral of sin 3x dx, and you have another dx. So x into integral of sin 3x is going to be minus cos 3x divided by 3 minus integral of derivative of x is going to be 1 into this integral of sin 3x is going to be minus cos 3x divided by, and you have a dx. Okay. So minus x cos 3x divided by 3 plus 1 by 3 into integral of cos 3x dx. So it will be minus x cos 3x by 3 plus 1 by 3 into sin 3x divided by 3 plus c, or it is minus x cos 3x by 3 plus sin 3x divided by 9 plus. Is it clear? Will we move on to the next one? So you have integral of x square e power x dx. So again, algebraic, 1 exponential second. So what will you have? F of x into integral of g of x dx minus integral of f dash of x into integral of g of x dx with respect to x. So what is f of x here? X square. Integral of g of x is integral of e power x dx minus integral of d by dx of x square into integral of e power x dx, and you have another dx. Okay, x square into integral of e power x is e power x minus integral of derivative of x square is 2x into integral of e power x is e power x dx. Okay, then you have x square e power x. Again, for this case, this will be first and this will be second. So minus 2 into what will I have? First function into integral of second function minus integral of derivative of first function into integral of second function. Okay. So you have the answer as x square power x minus 2 into x into e power x minus, here what will you have? Integral of 1 into integral of e power x is e power x and you have a dx. So the final answer will be x square e power x minus 2x into e power x minus of minus will be plus 2 into integral of e power x is e power x. So this will be the required answer. X square e power x minus 2x e power x plus 2 e power x plus. Okay. So if you observe this problem, what I did is, so we applied by parts twice. Did we do it or not? So first is for x square e power x. So in the intermediate step, you had an other product of two functions. For this, again, you start applying by products. Sorry, by parts. Right. So how do you know when you see the problem itself, you will know how many times you're supposed to do by parts? Who will tell you? Any idea or logic from this? So if you look at these kind of questions where you have the power of x, the degree of x will tell you how many times you're supposed to do by parts. Because whenever you have the combination of algebraic and exponential function, I repeat, listen to this carefully. When you have combination of algebraic and exponential function, who's treated as the first function? Algebraic. So what is happening in the by parts? In by parts, the first function is getting differentiated. So from x square, if I need to get a constant, how many times should I differentiate? That is why you need to apply by parts once. Had it been x cubed, would have applied by parts thrice. So thing is, depending on the power of x, you apply the by parts. Okay. So this is from the perspective of algebraic and exponential function. Now, I am going to explain you a method, okay, which first rule is don't use it in CBSE. Second, you can use it to verify whether your answer is right or not. So what are the two varieties of problems that we did? The first one was the combination of algebraic and trigonometric, and the second one was a combination of algebraic and exponential. I'll come to this. Suppose I have a combination of algebraic and trigonometric function. Okay. Let's take the first problem. What was it? It is integral of x into sin x dx. So whenever you have this kind of a combination, what you're supposed to do is write the first function as it is. So the method to solve the shortcut is, so what I'm going to explain now is shortcut. So the shortcut to solve is first function into integral of second function minus. So first function into integral of second function. That is, write the first function as it is, integrate the second function. Make the sign alternate. Minus, differentiate the first function, d by dx of first function into integral of second function. Then change the sign again, plus differentiate this function. d by dx of I. Sorry, first, what I've been trying to say is, you write the first function as it is, integrate the second function. Keep altering the signs. Okay, you start with a plus, put a minus, right? And then again, you put a plus. So you will keep continuing with this process till the derivative gives you a constant. So what you're doing is you're doing alternate differentiation and integration. To whom are you differentiating? first function. Now we are integrating second function with alternate signs into again integral of second. So it keeps on going. Okay. Now observe. If I have to apply that logic, right? So this is before arithmetic. Now I'll do one. Okay. So first listen, then you can copy it. So here, what is the first function? Algebraic. And second is trigonometry. So first write the algebraic function as it is. X into. What is the integral of sin x? Minus cos x. Now you forget the question. We're done with it. So I got the first step. So I started with a plus. Now I put a minus. Minus. I will differentiate x. What will I get? 1. I'll differentiate, sorry, I'll integrate minus cos x. What will I get? Minus sin x plus. This is the answer. If you want, you can cross check with the first. Understood? Yes. So, see, once you write this step, alter the sign, differentiate this, integrate this. Next step, had this not been a constant, differentiate this, integrate this. Okay. I'll tell you where it will help you first. Verify your answer. Let's say there is a 4-mark question and they are saying integral of x cube sin x. X cube sin x. So power of x is 3. How many times are you supposed to write? But if you use this, you will get it in one step. That one step will help you to verify whether your answer is right. If it is wrong, you can always go and check that where you are. For example, this is x cube. For example, this had been x cube sin x. Then how to do this? X cube into integral of sin x is. Okay, forget the question. You're done with it. Now you start from here. So next step. Since you started with plus minus dx square into integral of minus cos x minus sin x. Here you have a minus, the plus integral of 3x square 6x integral of minus sin x cos x. Here you have a plus here. Next step minus derivative of 6x integral of cos x. You can do and see in the long process as you get the answer. So if at all you go for any competitive exam, let's say in JEE, it's generally not much of this. Or any VAT or SRM. It's the same thing. I'm just writing the modified version. I suggest you what good on your own. Here. Okay. Similarly, we did another problem of what was the integral of x cos 3x. X square sin 3x. Right. X sin 3x. Okay, x sin 3x. What will be the answer? X into integral of sin 3x by 3 plus minus into right? You already have a 3. So this will be the answer minus x cos 3x by 3 plus sin 3x divided by 9 plus. I'll come to that. I'll go now. So this is how you show algebraic and trigonometric function. So the next shortcut that we are going to see is for algebraic and exponential. Very simple. You will enjoy this. Okay. So integral of I have algebraic and exponential of dx. So it is even more simple. What you need to do is you write the exponential outside. Okay. And write the algebraic as this. You started with plus 1, the minus a dash, the plus a double dash, the minus a triple dash. Like we will keep on going. Okay. Divided by, let's say, exponential function is e power x, for example. So the coefficient of x is a. So what you do is put an a here, a square, a cube, a power 4 and cube. See, though you call it as a shortcut, it's basically a logic. But what did I tell you? If you look at the by parts, who is being differentiated? First function. Is that not what we did? Who's being integrated? Second function. So when you integrate e power ax, first time when you integrate, what will be the denominator? If you integrate this again, the logic. And if you look at the by part, you have a plus and a minus sign, alternate on the sign. That is the reason why you have plus minus. Okay, now you do the second and third proposal. Integral of x square. What was it? X square. X square e power x. Here coefficient of x is 1. So how many times did we do when we went with the long method? At least 4 5 steps. Now say e power x into. First write down x square as it is minus 2x plus 2 and you're done. Check if this answer is. So as I mentioned in the beginning, 2 thumb rules. What is that? Don't use it in CBSE. Then don't come and tell me you lost marks. Okay. Second, use it only to verify your answer. They asked in MCQ, you should apply it as long as they are not expecting the steps. Here, so integral of x power 3 e power 2x dx. 1 minute time, do it fast. Integral of x power 3 e power 2x dx. So what is it? going to be e power 2x into x cube square derivative of x square minus derivative of x. And you should stop with this slide because if you differentiate 6 you're going to get it. And I'm coming to that. 5. You'll start with 2 cube, 2 square, 2 cube. Here. Shall we proceed to the next step? Integral of x log x. So according to Eilert, logarithmic function should be first and algebraic should be second. First, second. So you have to go with the original formula method. First function into integral of second function minus integral of derivative of first function into integral of second function. Right? So what is the first function here? Log x into integral of g of x is x square by 2 minus integral of derivative of first function. 1 by x into integral of second function. So it will be the same thing. X square by 2. Don't forget the dx. X and this will get cancelled. X square log x divided by 2 minus integral of the pure. So make a note. Keep trying. Go to the next one. What the next one? It's similar to what integral of x log 2x dx. So first function, second function, log 2x into integral of second function is x square by 2 minus integral of derivative of first function is 1 by 2x into same x square by 2 you write it here of dx. 1 and 2 will get cancelled, 1 x square. So you will get x square log 2x by 2 minus x square divided by 4 plus. This answer. So this 2 is the right integral of x is x square. Derivative of log x is 1 by 2x. Derivative of 2x is 10. So it is 1 by x into right. One last problem, x square log x. Log x into integral of x square is x cube by 3 minus integral of element of log x plus by x into the same thing, write it again. X cube by 3 dx, this one will get cancelled. You have x cube log x by 3 minus x power 4 divided by 6 plus. No. X cube by 6 plus. Correct. Just check the answer at the back. X cube log x by 3 minus x cube by 6 plus. I think for log you generally don't need it. So it's 2 by 9. Oh, 3. Generally for log you don't need a short because log is getting differentiated. So that's it for today. Next class we'll complete this. And 7.7 I think I'll delete it. Limit as something. Then we have definite integrals that I'll explain. Okay. So if possible, try these problems so that we can complete it faster and go to the next exercise. See, if integrals is done, mostly your syllabus will get done by October end. Because all other chapters are very easy. Applications of integrals. Definite integrals will limit as some no. Because you need to know the limits, you don't want to waste time on explaining. Because it doesn't have any application in other parts. The ancient method of definite integrals. But yeah, so once this is done, I'll go a little fast. Next chapter is applications of integrals like area. Only 2 exercises. You need to know how to draw the curves. The technique I'll teach you, problems you have to solve, bring it to. And differential equations also applications of integrals. It is the reverse process of differentiation. Then we have vectors and 3D. So vectors is almost your physics. So, but don't worry, I'll teach. Not like physics, I'll not leave you. I'll teach what is required for math. I'll do problems also. But I'm saying I'll go a little fast because you can understand it better. Then you have probability. Did we complete linear programming? No, linear programming. Did they complete in school? That's a very simple set. So it will be done this week. So be ready. Practice. That's it. Any other doubt? So October max. October end. I'll be done with October end. then mostly I'll give you TP first. Every day I'll give you 10 to 15 problems. You have to keep solving. I'm already preparing this. And you will have continuous assessments and assignment. You have to work for the option. So yeah, and remember you have to sit for 3 hours, right? Not like how you're doing. The class you sat and wrote for physics, no 3 hours. Every week you have exams on this. To develop patience, get ready, mentally prepared. So yeah. Okay, I'll see you then. Those were only any doubt there?
No, sir.
Okay, we'll wind up.
Thank you, sir.